Alright, shell method practice. We'll start with number 11. Given the region contained by y equals 2x minus 1, y equals square root of x, and x equals 0, find the volume when the region is rotated around the y-axis. So with the shell method for the y-axis, the volume is 2 pi, our interval from a to b, of the radius times the height, and that'll be in terms of x if we go around the y-axis. So keep that in mind. Y-axis means dx in terms of the shell method. So the next thing to do is kind of draw this out. So let's make it fairly big. 1, 2, 1, 2, 1, 2, all the way around. So let's see here. The lines we have are y equals 2x minus 1. So that's a y-intercept of negative 1, and a slope of up 2 over 1. Again, up 2 over 1. And eventually we have the straight line that should create. So that's y equals 2x minus 1. Next we have y equals the square root of x. That starts at 0, 0, goes to 1, 1. So that region is kind of picked up very quickly. And then bind to x equals 0, we get this little, not triangular exactly, but kind of triangular looking, kind of going over the first and fourth quadrant. And remember, we're going to wrap this around the y-axis, so it'll be mirrored on the other side. So there will be a straight line coming up and kind of coming down. So if we draw it right, kind of like a butterfly. Let's kind of capture that. So let's see if we can draw that out. Well, write it out. So volume equals 2 pi. My y values are going to be from negative 1 to positive 1. Okay? So it goes a little bit below the, I'm in x. I'm in x. My x values will be from 0 to 1. See, caught myself there. That's good. The radius will be x out from the line of rotation to some point, and the height will be the top curve minus the bottom curve. So that top curve is square root of x, which is x to the 1/2, and the bottom curve is 2x minus 1. So let's see here. Let's do an extra set of parentheses here. 2x minus 1, so we don't get lost there. So just to make sure you're okay here, the x is the radius, and the difference between these two curves is the height. Okay, so the green one is the top one, and the blue one is the bottom one. Okay, and everything is in terms of x, so everything looks really good here. So let's see if we can clean it up before we integrate. So volume equals 2 pi from 0 to 1. I'll distribute this x through, so it'll be x to the 3/2, and then through the next place it'll be minus 2x squared, and it'll be plus x dx. Now we got to integrate. So this interval will be 2x, and what do we have? We'll have x to the 5/2, so that'll be times 2/5, minus 2/3 x cubed plus 1/2 x squared. And that'll be from 0 to 1. Okay, so let's see if we can fix that. So we'll let x equal 1. Okay, so we got 2 pi. We'll plug in 1. We'll have 2/5 minus 2/3 plus 1/2. Going to be some common denominator going on there. And then minus, and we'll let x equal 0. That's just going to be 2 pi times 0 minus 0 plus 0. So all that's gone. So let's see what happens here. We're going to need a common denominator. I'm going to leave the 2 pi out front. Why are you there? 2 pi. 2 pi. So I've got denominators of 2, 3, and 5. Let's make them all 30. So 2/5 will be 12/30. And 2/3, that will be 20/30. And 1/2, that'll be 15/30. So let's see here. That's 27 minus 20. So that's 2 pi times 7/30. So that is 14/30 pi, which I guess is 7/15. But since we're running out of room, we'll just stop right there. All right. Let's see if that's correct. And then we'll come back and... Yes, I checked in the back of the book. They got 7 pi over 15. So yes, we have the right answer. Good job.